Today, we are answering an age-old, very scientific and important question. What if the moon crashes into Earth? It's more interesting and weird than you probably think. Let's start with the basics. Why isn't the moon on its way to crash into us already? We know that Earth's gravity pulls everything towards it, including the moon, but somehow it stays up, as if suspended by some opposite force. But there is no other force countering gravity. Instead, the trick to staying up is a sideways motion that we call an orbit. You see orbits every day. When you throw a ball, it makes a tiny little orbit. The only difference between the ball's orbit and the moon's is that the ball eventually hits the ground. Basically, the reason is speed. If you could throw your ball fast enough, it would bend around the world and come back to you. If there were no air slowing it down, it could orbit forever. And this is what the moon does, falling sideways around Earth very fast with no air slowing it down, orbiting Earth every 27 days at 3,600 kilometers an hour. So, for the moon to just stop in its orbit and plummet to the Earth would break more laws of physics than we have time to explain. So, how do we crash it into Earth? In a nutshell, to change an object's orbit, you need to change its speed, which changes where gravity takes it. But even small changes require enormous forces, which is why all the large objects in the solar system are so stable nowadays. According to science, the moon is big and very massive. Even igniting billions of rocket engines all over its surface would barely move the moon. It looks like nothing short of magic will make the moon fall, so we'll use a magic spell that slows down the moon so much that it changes its orbit and spirals towards Earth. To get the most from the experience, the moon will take exactly 1 year before it hits Earth. Ready? 3, 2, 1. Magic! Month 1. For the first few days, nothing really changes. The moon gets a tiny bit brighter and scientists get confused, but the rest of us don't notice anything different. The only noticeable real effect of the moon on the Earth are the tides. Tides exist because while Earth pulls on the moon's gravity pulls back on the Earth. Since the strength of gravity gets weaker with distance, different parts of the Earth feel a slightly different pull, which causes the Earth, especially the oceans, to bulge when the moon is above them and contract a little on the sides when it's not. As Earth rotates every day underneath the moon's influence fluctuates, causing the water level of the oceans to rise and fall by about half a meter twice a day. But with the moon drawing ever closer, high tide gets higher every day. At first barely noticeable, within a month the moon has covered half the distance to the Earth and ocean tides have grown to 4 meters. Every day high tide comes and waves flood coastal cities. And there's no end in sight. With the moon drawing ever closer, tides rise ever higher, inundating another city and more inhabited land with salty water every day. Month 2. By the end of month 2, the moon has covered 2/3 of the distance to Earth and global infrastructure is crumbling as tides rise above 10 meters, displacing up to 1 billion people who happen to live near the coastlines. As ports become inoperable, shipping grinds to a halt. Not only will it slow down the delivery of Kurzgesagt products, but also less exciting things like food. Global communications fall into disarray. 95% of the internet is carried by ocean-crossing cables, and while these largely don't mind the water, their terminals on land do. Living inland doesn't guarantee safety either. Tidal bores cause rivers to flow backwards, carrying salt water to contaminate surface and groundwater supplies. Gas shortages follow as oil refineries near the coast are abandoned. Countries are left with the supplies they had on their shelves, and strict rationing will begin. In the cities, chaos reigns during the scavenging hours of low tide, while survivors take refuge in high-rises when the water returns. Month 3. 3 months in and the moon is close enough to disrupt communication and navigation satellites. While it's normally far too distant for its gravity to cause any major problems for our satellites, the closer it gets, the more warped their orbits become. As their fuel for orbital corrections runs out, satellites careen out of control. Months 4 and 5. On Earth, the tides are rapidly growing to about 30 meters and will be reaching 100 meters in height in a few short weeks. At low tide, the ocean recedes hundreds of kilometers, exposing the continental shelf like vast deserts, while at high tide, walls of water drown agriculture, houses, and skyscrapers. And now, almost 5 months in, the apocalypse has finished its warm-up act. Since the oceans are on average only 3 kilometers deep, the tides have reached their maximum. Up until now, the water in the oceans could flow, absorbing most of the moon's gravitational squeezing, but now the Earth itself is really feeling the squeeze of the ever-approaching moon. These aren't so much tides of water, but tides of rock. The squeezing of the planet, combined with the weight of quintillions of tons of water sloshing on and off the tectonic plates, creates enormous stresses below and begins to cause earthquakes of increasing magnitude and intensity. It's impossible to say how serious these earthquakes might be or where they occur, but like a child jumping on their bed until it breaks, no good can come of it. Strong tidal forces lead to volcanism on other planets and moons. On Earth, squeezing the planet disrupts the magma reservoirs inside the crust, triggering sizable, climate-altering eruptions in Chile, New Zealand, Yellowstone, and elsewhere. Meanwhile, watching patiently above is the moon. Still no bigger in the sky than a small cloud. Within 75,000 kilometers of Earth, it is bright enough to illuminate the night sky like twilight. Months 6 and 7. After half a year, the moon is entering the space once occupied by geosynchronous satellites, where it orbits Earth every 24 hours. It appears to float at one spot in the sky, unmoving, cycling through a full set of phases every day, but only visible to half the planet. With the moon stationary above the Earth, the tides seem to freeze in place. Half the world flooded, half with its water seemingly returned to the sea, as if Earth is holding its breath to prepare for the worst. As the moon sinks further, you might wonder if its gravity would overpower Earth's, pulling you up and ending your misery. Fortunately not. The Earth's surface gravity is about 6 times stronger than the moon's, so even if the moon were hovering right on top of you, you would still stay on the ground. On the moon, things are different though. The near side of the moon is more strongly affected by Earth's gravity, so during the next few months, it starts to stretch forward towards the Earth into something of an egg, triggering deep moonquakes as the lunar rock flexes and changes shape. Though barely noticeable now, this squish will grow to hundreds of kilometers in a matter of months. Months 8 to 11. At this point, the apocalypse has arrived, and we can summarize the months before the crash as everybody left has a really bad time. The tides sweeping over the Earth slow down and then reverse their direction because the moon now orbits Earth faster than it rotates. The planet will experience an abundance of earthquakes and volcanism. Massive amounts of volcanic aerosols rise high into the stratosphere, shiny enough to reflect sunlight back into space. What little light gets through is rust red and is periodically diminished by daily eclipses. The result is a rapid global cooling with acid rains and summer snows killing even the hardiest plants. The clock runs out on civilization. Billions have perished while an X-shaped moon is still drawing closer. Let's get ready for the grand finale. Month 12. Finally, at the end of the year, the moon has reached the Roche limit. That's the point where Earth's gravitational pull on the moon is stronger than the moon's own gravity. Things on the lunar surface start falling towards Earth, and by the time it crosses 10,000 kilometers, the entire moon disintegrates into rubble, smearing itself into a massive ring system around the Earth. Fortunately, the moon's disintegration means the misery on Earth has ended. No moon means the general apocalyptic nature of things comes to a halt. The oceans recede, flowing off the land one last time. Any survivors are treated to a view of tremendous arches spanning the sky, glimmering in the sunlight, illuminating the night sky more brilliantly than any full moon ever could, while meteor showers of moon dust fill the sky. It's hard to say what happens next, but the tranquility may be short-lived. If too much moon dust rains down, friction heats the atmosphere, possibly boiling the oceans. If not, the enormous shadows cast by the rings, combined with all the volcanic and meteoric aerosols, block even more sunlight, and a period of runaway cooling could begin that freezes much of Earth's surface solid. In any case, at some point people will emerge again, from submarines or bunkers or mountaintops. They will not have a great time before rebuilding civilization, and their success is not guaranteed, but at least they'll be trying to do so with beautiful rings in the sky.